My dear students, today we are going to learn about the classification of elements with respect to electronic configuration, or you can say how the differentiating electron enters in which subshell that gives the black of that particular element, that belongs to the black of particular element. For example, modern periodic table is classified on the basis of the differentiating electron, that is the last electron, enters in the subshell. If it enters in S subshell, that element belongs to S black. If last electron enters in P black, P subshell, then that element belongs to P black. If it enters in a D subshell, last electron enters in differentiating electron. Last electron means differentiating electron enters in a D subshell. We used to say that element belongs to D black. So, SPD blacks we have already dealt in the previous video. Now, the F black means according to the definition, the differentiating electron, if the differentiating electron enters in F subshell or n minus 2 F subshell, n is the outermost shell, then that is called ultimate shell, n minus 1 will be the penultimate shell, n minus 2 will be the anti-penultimate shell. The f orbital in anti-penultimate shell causes if the electron, if the differentiating electron enters in anti-penultimate F subshell, then that element belongs to F black. The F black elements are also called as inner transition elements. In these elements, outer 3 subshells are incompletely filled. That means ultimate shell, nth shell, n minus 1 shell, penultimate shell, n minus 1 shell is called penultimate shell, and n minus 2 shells, that is called anti-penultimate shell, last but 3 is third shell. These 3 shells are incompletely filled, hence they are also called as inner transition elements. Why F black elements are called inner transition elements? Because in these elements the outer 3 shells, outermost 3 shells n, n minus 1, n minus 2 shells are incomplete filled. So, these are called inner transition elements. These elements belong to third B group. The lanthanides, that is 28 elements which are kept at the bottom of the table. This is S black, P black, D black, F black. This is total 28 elements are kept in this same group, third B group. After S black, third B group it starts. In the third group, scandium group, that is, in that group itself these 28 elements also kept. So, total 32 elements are present in third B group, which is the longest group. If anybody asks how many elements in that group, you can say then 32 elements are present in third B group. So, it is a longest group which contains 32 elements, in which F black elements also present. They are F black elements are 28 elements which are 4F series. 4F series, that means differentiating electron enters in 4F subshell. Such elements, F black F orbital can accommodate 14 electrons. So, you will get 14 elements. Those are called 14 elements which are 4F series, 14 elements which are called lanthanides. Lanthanides, why they are called lanthanides? They are coming after lanthanum. Lanthanum element 57 atomic number. After lanthanum, the 14 elements are coming in the periodic table, that is starts from cerium 58 atomic number to lutetium 71 atomic number. So, total 14 elements are present in the 4F series, those are called lanthanides. So, lanthanum is a D black, but lanthanide is a F black. Why they are called lanthanides? Because they are coming after lanthanum, atomic number 57th element, that is lanthanum. So, these 14 elements coming After lanthanum, those are cerium to lutetium, 58 to 71. These are called lanthanides. They occur rarely in the nature, so they are also called as rare earth elements. Lanthanides occur rarely in nature, so they are called rare earth elements. And another 14 elements are there. Those are coming in 7th period. In 6th period, lanthanides are there. In 7th period, 5f orbital is filling with by df differentiating last electron, that is a differentiating electron. So, those are called actinides. Why they are actinides? They are coming after actinum element. Actinum atomic number is 89. So, they are coming that is these 14 elements starts from 90 thorium, that is equal to 92, lawrencium, that is equal to 103. So, these elements are called actinides or actinoids. They can also called actinoids. They are 5f series of elements. All these elements are radioactive elements. Most of the radioactive elements are present in F black, that is in 5f series. That are also you can say in the form of actinides. Most of the radioactive elements in which black they are present? They are present in F black. In which series that are present? They are in actinides. Actinides belong to which period? 7th period. Lanthanides belong to which period? 6th period. Which group? Lanthanides and actinides or F black elements belongs to which group? 3rd B group. 3rd B group, how many elements are present in 3rd B group? 32 elements. So, these are so many bits we will get in F black elements. Next question, in the form of question you will get that is classification of periodic table on the basis of incomplete or complete outermost shells. Complete shells by electrons. The complete shell means cell total completion of cell is not 8, not 18 or 32, simply 8. So, complete outermost shell, if outermost shell is completely filled, such elements are inert gases. Only outermost shell is incompletely filled, those are called representative elements. Only outer two shells are incompletely filled, they are called transition elements. Outer 3 shells are incompletely filled, they are called inner transition elements. On the basis of the incompletely or completely filled outermost shells, they can be classified into 4 types. First type is inert gases, second type of is representative elements, third is transition elements, fourth is inner transition elements. Let us see what about inert gases. They have completely filled outermost shells. Their configuration is NH2 NP6 except helium. Helium has only one S2. They are He, helium, neon, argon, krypton, xenon, radon. They are called 0 group elements, or you can say 18th group elements in the long form of the periodic table. They are inert in nature because of completely filled orbitals or subshells. They are lethargic or they are inert in nature. So, they are called inert gases, or you can call them as noble gases. Next category is representative elements. Second category representative elements. They have incompletely filled outermost shell. That means outermost shell 8 electrons, to complete 8 electrons are required. 8th electron is completely filled, that is inert gases. So, the remaining NS2 NP5, NS1, it starts from NS1 and ends with the NS2 NP5, such 7 groups are present in these elements. They are called representative elements. Their outermost shell is completely filled. They have general configuration NS1 alkali metals, 2 NS2 NP5 halogens. NS1 first group, first A group, NS2 second A group, NS2 NP1 third A group boron family, NS2 NP2 that is carbon family, NS2 NP3 nitrogen family or natcogen, NS2 NP4 oxygen family, they are also called chalcogens, NS2 NP5 they are halogens, NS2 and up to these 7 groups, it contains 7 groups. They are first A lithium, sodium, potassium, rubidium, cesium, and second A group beryllium, magnesium, calcium, strontium, barium, radium. Third A group boron, aluminum, gallium, indium, thallium, and fourth A group carbon, silicon, germanium, tin, lead. Fifth A group nitrogen, phosphorus, arsenic, antimony, and bismuth. They are called they are nitrogen family. It is called natcogens. They are mineral forming elements. Next, 60A oxygen, sulfur, selenium, tellurium, polonium. They are chalcogens. They are mineral forming. They are ore forming materials elements. So they are called chalcogens. Mineral forming elements. Oxygen, sulfur, selenium, tellurium, polonium. And 7th A group fluorine, chlorine, bromine, iodine, astatine, they are called halogens. Halos means sea salt producers. They form sea salt, they are the cause for the sea salt. Sodium chloride, it means main ingredient in sea water. Fluorides, those are called sea salt producers, they are called halogens. So how many groups are there in the representative elements? 7 groups. 7 what are they? First A alkali metals, second A alkaline earth metals, third A boron family, fourth A carbon family, fifth A nitrogen family, and sixth A oxygen family, seventh A halogens comes into this category. Next is transition elements. Transition elements, the outer 3 cells are incompletely filled, that is nth cell and n minus 1 shell. Ultimate shell and penultimate shells are incompletely filled. Their general electronic configuration is NS1 or 2, n minus 1, D 1 to 9 you can write, NS1 2, n minus 1, NS2 2, n minus 1, D 1 to 9 you can write, but in the ninth for completely filled d orbitals, one of the electron comes from s orbital. So NS1 n minus 1 D10 will be happened, copper group you can see. So except zinc group completely filled d orbitals there are there. So incompletely filled d orbital should be present. That is the reason most of the scientists do not consider zinc group is a transition element. So D black, zinc, mercury, zinc, cadmium, mercury, these are the zinc group elements. They are not considered as a transition elements. So transition elements are exhibiting special properties due to incompletely filled electrons. What are those? They are all metals. They form alloys. Metals, they transition all D black elements. You can say transition, most of the D black elements are transition elements. So you can say either if you ask properties of D black elements or transition elements, you can write all these 9 points. It is very important. Write a short notes on transition elements, write a short notes on F black elements. These are the main questions for intermediate students. So you have to know what are the salient properties of transition elements. All transition elements are metals, the first property. When they are metals, 2 or more metals homogeneously mixed to form alloys. For example, copper, zinc, brass, copper, zinc, tin, bronze, copper, zinc, nickel, German silver. So alloy, those are called alloys. They can form alloys. They are as they are metals, all these metals are good conductors of heat and electricity. Heat and electricity, metals are, metals are good conductors of heat and electricity. They have high melting points because they are very strong metallic bonds. Due to the presence of strong metallic bonds, they won't easily melt. So, requires 300 to 400 degrees centigrade, 4000. So, 2000 to 3000, 4000 degrees high temperatures are required to melt these elements. That means they have high melting points. They are hard and tough, hard and tough. Hard because of the metallic bonds, they are very hard. So, so you see iron is a hard metal. Similarly, gold, copper, tungsten, these are all strong metals, hard metals, and they form colored compounds. Colored compound, they form colored compounds. For example, copper sulfate. Copper is a D black element, copper sulfate is a blue color. Iron chloride is some orange color, red color you can say. Similar way, potassium permanganate, manganese is some pink color. Like that, they are colored, they form colored compounds, or they form colored ions or complexes also. Ammonium sulfate, copper ammonium sulfate is a bluish in color. So, they form colored compounds, colored ions and colored complexes also. They are paramagnetic in nature because due to presence of unpaired electrons. If any compound, any material having unpaired electrons, they are paramagnetic. They are attracted by the external magnets. Such nature is called paramagnetic. If they repels, that is called diamagnetic. Dia repels by the external magnet. Such compounds are called diamagnetic. If a material attracted by the external magnet, that is called paramagnetic. All these are having unpaired electrons, so they will be attracted by the external magnet. So, they are paramagnetic in nature. They have high densities. Hard and high densities also. They form stable complexes. They form stable complex, ammonium sulfate, potassium iron forms ferrocyanide. Potassium ferrocyanide is a complex. So, later in D black elements, you can in second year you will learn what are the complex, what are the primary valency, what is the secondary valency, why they are form so much complex natured compounds. So, that can be known in a D black elements chapter detailed way. Now, F black elements already we have seen. So, another one is inner transition elements. So, the fourth one is inner transition elements. All properties I have already dealt in the first slide. Next comes periodic property. Periodic property. What are the periodic property? Any property of element that shows a gradual change, that is increase or decrease in a period, or repeats same property in regular intervals in the long form of the periodic table. Such nature is called periodicity, periodic property. So, the seasons are periodic in nature. For example, winter, next comes summer, next comes rainy season. Similarly, days are periodic in nature. Sunday, Monday, Tuesday, Saturday, after Saturday again Sunday comes. So, that nature is called periodic nature. In regular intervals, the change, that is change of properties, whether they may increase or they may decrease, or they may similar in regular intervals. Such a property is called periodic property. They may be physical property or chemical property. So, they may be physical or chemical properties of elements in periodic table. Let us see which properties are changes gradually in a period or group, gradual and similar in a group or period. So, let us see some physical properties. See atomic volume, atomic size, melting point, boiling point, density. These also gradually varies in a group or in a period. So, those are physical properties. What about chemical properties which are which period? He will ask in some 2 marks question or 4 marks question. What is periodic property? give examples. How these properties vary in a group and period in long form of the period table, like that it may be asked. So, first of all you have to know what is periodic property, what type of what properties are changes in the periodic table when you go in a period from left to right in a group from top to bottom. Chemical properties, electronic configuration, ionization enthalpy, that is called ionization energy, electron affinity or electron gain enthalpy, electron negativity, metallic nature or non-metallic nature, nature of oxides, basic nature of oxide, basic nature or acidic nature you can write, you can see how they are changes in a group or period, valency, how the valency varies in a period, in a group, how it will be similar, oxidation states, and reducing properties or oxidizing properties. So, these are also have some gradual changes in periods and groups in the long form of the period table. So, they are chemical properties, they are related with the electrons due to flow of electrons or due to giving or gaining of electrons. So, these are the number of electrons. So, it related to electrons mostly, that is the reason they are chemical properties, whereas physical properties simply how the physical strength of the bonds, how the sizes and everything will be told, the atomic sizes, atomic radius, ionic radius, metallic radius, these are all comes in physical properties. Chemical properties, what are the chemical properties of periodic properties? Electron configuration, ionization enthalpy, electron affinity or electron gain enthalpy you can say, electronegativity and metallic nature, nature of oxides, valency, oxidation states, reducing property. Generally which properties, mostly in bit NEET or something, which property is not periodic property of elements in the periodic table. Properties of elements that are not periodic nature are specific heat, color or refractive index. These are not periodic properties, they are not gradually changes or similarity in regular intervals are not happened in these cases. So, they are not periodic properties. So, let us learn afterwards after knowing the each thing anyway. So, I will show what happens atomic size, atomic radius or atomic size as you move from top to bottom increases, and electronegativity decreases because increasing side the arrow this sharp head indicates increasing side. So, here electronegativity decreases, ionization enthalpy decreases, electron enthalpy, electron gain enthalpy decreases. These three are friends. What are those? Electronegativity, ionization energy and electron gain and enthalpy, they decrease as you move from top to bottom in a group, whereas the atomic size increases in a group due to increase in number of orbits, or you can say. Later we will discuss detailed way in every property so that you can answer AP set bits or NEET or JEE bits. So, what about when you left to right in period you go ionization enthalpy increases, electron gain enthalpy increases, electronegativity increases. These are friends. Whatever this do, this also same in trend and this also same trend in a period. But reverse trend is atomic radius. These three are reverse are opposite to the atomic radius. Atomic radius decreases as you move from left to right. Ionization energy, ionization gain enthalpy, electron gain enthalpy, ionization enthalpy and electronegativity all are increased as you move from left to right, whereas atomic radius decreases. In diagonal direction also there are some similarities in properties. Such properties are generally called as diagonal relationship. We will see later in detailed way all these trends, all the trends of these periodic properties. So, thank you. Please subscribe.